Okay, so I'm Chris Ellis. I'm kind of head of technology here at Next Team, and at Posette 2024, I'm going to be talking about JSONB with Postgres still needs some form of schemas, right? And this is a talk very much about dealing with those kind of situations where you don't really know what data you're storing all the time, or you're dealing with kind of quite complex data structures that you don't really want to just map into tables. And it's going to explore and look at just the basics of Postgres JSON support, and then how we can kind of use that to actually control the kind of data we're storing in our database. So to avoid those kind of like spaghetti data situations that it's all too easy to get into when you're dealing with kind of unstructured data. And just going to talk through that, so some pure SQL, and then look at an extension that can kind of help people out as well. And it's very much about those times where you just want to kind of ensure the integrity of your kind of database. So first off, a little bit about me. So I'm Chris. I'm kind of based in the UK in London, and I tend to go around calling myself a bit of an IT jack of all trades. I've kind of pretty much can do everything from building hardware and designing hardware up to kind of designing and building front ends, although not necessarily the most pretty. But I obviously spend most of my time kind of dealing with back end engineering and databases. And I've been using Postgres for quite a while now, for about 18 odd years. And I've worked on a whole range of kind of projects, from kind of just simple website searches to also kind of smart energy kind of IoT type applications where we had a multi-terabyte database processing kind of lots of different data reads and kind of all lots of fun processing. And also kind of like just some simple small applications such as like booking and subscriptions management platforms. So a huge range of kind of different things. And this talk, like a lot of I tend to do, is all based on kind of my experience and kind of what we kind of have run into or what problems we wanted to solve. And this project very much directly is actually related to some problems I've kind of been dealing with in a very current project. And some discussions we had as a team about like how we could try and maybe improve this. And one of the kind of things I tend to find often we have to do in databases is deal with those situations where we've got either quite complicated data structures that we need to store, and often it doesn't necessarily make sense to map all of those into individual tables and as relations, right? Sometimes you just don't have the development time to do that. Sometimes it's just way more complicated than it needs to be. And that's where we had things pop up in the past, like a bit like the entity attribute value model, especially for dealing with those kind of times where you've just got to store data that you don't know about, and you don't know the shape of it in advance, and you don't know what it is. So there's a whole bunch of different use cases where we're going to have to store kind of data. And let's be honest, these days, JSON has become kind of pretty much the king of how we handle and interchange kind of what we might call, say, loosely structured data. Obviously, definitely replaced XML in that regard. But I think a key question here is, well, is Postgres the right tool for this job? And to my mind, of course it is. But we could have maybe just stored some of this in a file, or maybe we could have put it in MongoDB. But really, what you tend to find in these situations is you want to tie up the data between your main kind of relations and then this kind of data that's a bit on the side that maybe you only need it because a customer needs to store some custom metadata against certain records of your core data set. And you don't necessarily need to use this all the time, but often when you want to use it with the data that you've already got and you've structured well in a nice relational way. And this is where Postgres and its kind of JSON support can be a huge advantage for dealing with these kind of like more modern hybrid data models where we want to deal with these different types of data all in one place. And, actually in Postgres, like how we store and deal with this is just as simple as a data type. Postgres has completely pluggable data type system available, and we have a data type called JSON, and we also have a data type called JSONB. So the JSON data type is effectively just storing JSON data as text in Postgres, but with the added layer of it being validated as an actual valid JSON document. JSONB is a bit more complicated and doing a lot more processing. We're actually storing a complete binary representation of that kind of JSON document inside Postgres internally. So again, we're doing a lot of kind of processing here. It has to be valid JSON document because we have to have parsed it and split it all into its underlying tokens, stored it in our kind of binary format internally, and kind of all of that kind of jazz. So with JSONB, we do get situations where like things like object property orders can change a little bit because they're not, guaranteed. They get normalized and all that kind of stuff. But Postgres also doesn't just have these as basic data types. We've got a whole bunch of support framework around it. We've got a whole bunch of functions that can work with these data types, and we have a whole bunch of operators that can work with these data types too. So we have operators to go and fetch properties. We have functions to go and build objects and inspect objects and all that kind of stuff. And we'll go through a few of them briefly here to kind of get a bit of an understanding of what we can do, and then how we can go about kind of controlling those data that we're loading. So we've got to start off with putting that data in. And to do that, right, it's just a straightforward insert command, right? All we're going to do is just cast the kind of text into a JSONB data type and insert that. And this is also where Postgres's kind of dollar quoting format is super handy at being able to handle, especially multi-line kind of JSON documents, and you don't have to deal with kind of quoting too much. You can also put a word between the two dollar symbols to make sure that you don't match it $$ inside the document, etc. But inserting this data is just as simple as basic insert statement. But now we want to actually start using this in our application. Well, then the really basic thing we want to do is probably just pull a couple of values out of that kind of underlying document. So we got two kind of arrow style operators here that let us kind of go and fetch a property from a document. So in these two situations, we got the double-headed arrow here, which is going to fetch the property PLN code from our kind of column. So it's obviously going to fetch that kind of property from the root kind of object of that document. And we're going to actually, in that particular operator, we'll actually return the result as a Postgres text type. So that's very handy if you would then want to pass it into other Postgres functions. The second form of this operator actually returns the property value as a JSONB type or a JSON type. So that actually allows us then to chain these kind of operators together if we want to drill through kind of a nested layer of things. So for example, if we wanted to access the width property of the dims property here, we can just do another kind of arrow operator. And that's kind of very handy. We also actually have built-in operators and functions to deal with complete path lookups if we need. But this is just the basics, right? And this is kind of doesn't just have to be for usage in select lists. So we can also actually do this in the kind of where clause. So we can actually kind of pull a property out and then match on it, just as we could kind of any kind of Postgres expression or function or operator. And this lets us kind of just do that kind of very basic predicate. Obviously, this particular instance here, we could maybe kind of speed this up by using an expression index. But if we want to actually be able to look up random properties, we kind of have to do things a little bit differently. But Postgres's support here is, again, really good. And we can actually create an index on a JSONB value. So we can actually create a GIN index on a JSONB column, and that's going to then let us search by arbitrary properties, especially within the root of that object, for when we want to search. So if our use case needs that we need to be able to look up particular property and value pairs from this kind of document in a performant way, then actually JSONB is kind of great for this, coupled with the GIN index. We have to use a slightly different operator here to query it, right? So we can't just use the same kind of arrow style in equals, because that can't be pushed down to the index. But we can use a different operator here, which is this kind of at arrow thing, which is effectively what we'd call a contains operator. And if you've ever played with Postgres arrays, then you'll have noticed this operator is kind of the same there, where we can kind of check if two arrays contain each other, etc. And we can use this here to say, effectively, does my kind of JSON document that I've got in my column contain the property CRM code and the value CRM114? And the great thing here is, and we can check this by looking at an explain plan, it's going to go and hit that GIN index. It's going to search that GIN index, and then it's going to do a quick recheck against the heap, because GIN indexes are lossy and all that kind of stuff. But this is kind of super powerful. We now actually have a situation where we can just store kind of arbitrary data and we can query on it. So if we have a simple use case where we need to let our customers who are consuming our APIs to store their own reference data against what we've kind of stored in our database, we can really easily achieve this with JSON and JSONB, and we can still do fast lookups. So that's kind of one of the things we were doing in a recent application. But the downside to this is kind of letting your customers or letting your users store arbitrary JSON documents into your database. Things can go wrong quite quickly. And it's very easy to build that kind of tangled mess of wires with you don't really know what's in your kind of database anymore. And definitely worked on some other kind of key value store databases where that's been a real problem. Nobody validated anything before they put it in, and not everybody actually does the validation in their application layer that you can necessarily trust. So I'm always a big fan of making sure that our database enforces integrity as well. So like, we can trip ourselves up here by this insert statement will completely validly run, right? We can insert an array, we can insert a number. Even more fun is we can insert a JSON null, which we have to remember is not the same as an SQL null. They are two sort of different things with the SQL's love of kind of tri-state logic. But that's not necessarily what we want to use and store. And at the end of the day, our kind of access operators are not going to blow up or anything here, right? They're not going to error, but they're not going to do what we want. And errors might just be a bit more subtle, right? It could be that we mistyped the name of a property, could be that we accidentally nested that kind of object twice, or maybe we accidentally wrapped it in an array, right? These are much more subtle and would be very easy for you to kind of introduce in your application layer, and without being able to enforce just even some basic shape and properties of your data in your database, it's going to introduce bugs further down the line. And I think all of us who work in kind of databases, we kind of like order. And I don't just mean order by here, right? We like data integrity. We have foreign keys for a reason. We like to use foreign keys for a reason. We like to use not null constraints. We like to use primary keys, right? All of this helps us as a whole system to enforce the value of our data and usage of our data and reduce maintenance burden as we go across the life of our project. So with that in mind, right, we've got this kind of trade-off of we want to be able to store unstructured data, but we also want to be able to kind of control at least some basic properties of that. So we can kind of do that. And the first part of that is we need to be able to make some basic assertions about that data, right? So a really basic thing we might want to at least assert is let's try and make sure we can only insert JSON objects into that column. So to be able to do that, we need to be able to find a way to specify, well, I've got this JSON value, what is it? And Postgres has a function called JSONB type of, and that lets you effectively do the equivalent of the JavaScript type of operator, which is going to tell you, like, well, in this particular instance, it's going to return the text array. If we pass it an object, it's going to return the text object. If we give it a string, it's going to return the text string. So we've now got a really fast way to know the kind of type of a kind of document or the root level of a document or particular property that we pulled out. And so at least we can now go and clear up all that bad data about our database, right? We can just delete every row where the kind of type of that thing is not an object. But that's only so good at sorting out the mess we've got into, right? We want to actually make sure we don't get into that mess again. So this is where another very awesome power of Postgres comes in, which is check constraints. So check constraints let us apply an arbitrary predicate onto our kind of record and to ensure that it matches a whole bunch of criteria. Now, this is just specified as an SQL kind of predicate expression. So we can do kind of anything we can in Postgres with the kind of requirement that that kind of check is what we might call, say, idempotent, right? So if we give it the same value, it's always going to return the same result. So a key property of that is our expression that we specify on a check constraint cannot go and look at data in other tables. So we can look at pretty much all the columns of our row, and we can apply a whole bunch of functions to that, but we can't go and do a query on another like reference table, right? That's exactly what foreign keys are for. Check constraints aren't meant to do that. So now we've got these kind of two things. We can kind of construct that check constraint, and now if we try to insert our kind of bad data again, well, what's going to happen? Well, like everything, we're just going to get a constraint violation, right? So Postgres has gone, well, I've gone to run this check against your expression, against the value you're trying to insert, and it's violating a constraint. And obviously it tells us a little bit more detail than I've omitted on this slide, but it's going to throw an error if we try to stick bad data in now. So now we're in a situation where at least we can only store just basic object documents. But life is a bit more complicated than that, right? And the whole point of using a lot of this data is probably we want to store a bit more structure. So we want to deal with kind of a bit more complicated forms of JSON documents where we might have nested things, we might have arrays of stuff, and we want to be able to at least be able to assert a bit more detail here, right? So how can we go about that? So first off, let's move on our example and make our example a bit more complicated. And one of the things we've been doing on our project is dealing with kind of rules engines a fair bit. So we're storing kind of a JSON blob of all the rules into a table. And that's a basic structure of, we've got a bit of kind of metadata about the rule set, and then we have basically a list of rules that need to be applied. And what we want to do here is we want to be able to insert this into our table, but we want to make sure that we're always inserting a valid kind of rule set. So we want to make sure that it's got these kind of basic metadata properties. We want to make sure it's got an array and all the elements of that array are an object, and that each of those objects themselves have got different, the kind of 3 properties we need, like the fact, the operation, the value. Now, how can we go about that? Well, we've learned enough already in this talk so far to be able to sit and say, well, I know I can assert the kind of type of the root of this document. I know how to go and look a property up in the document. So I can check that that's not null. I can check that that's defined. I can then check the type of that property. So we can go and call type of on the result of that property lookup, right? And remember I said the kind of single arrow operator here is going to return a JSONB type, right? So because we returned that JSONB type, we can then use the type of function, and that's going to tell us it's a string. So now it's very easy for us to make a whole bunch of very basic assertions inside our check constraint about what we're inserting. But we can get a bit more complicated here, and we can use a bit more power of Postgres's JSON support and also just standard SQL here to do even more deeper checks. So we can take here a kind of, so Postgres has something called set returning functions. Now, these are functions that will basically return and generate a table for us, right? Probably the one that everybody knows is the best is generate series. But for JSON, we have a whole bunch of these, and we have one called JSONB array elements. And that's going to take a JSON array value, and it's going to return a row for every element in that array. Now, that's great in that has kind of bridged that JSON array back into the kind of SQL world, where we can now use the power of SQL to process it. And we can use an aggregate function here. All we want to do at the end of the day is just compute that every element of my array valid according to some kind of check. Well, Postgres has a whole bunch of very cool aggregate functions, and a very neat one that's probably not used very much is called bool and. And that's just going to give you a logical OR of every kind of value it sees. So if we just do a bool and aggregate of all of our kind of checks across each element, we just get a Boolean that says, well, this array is valid or it's not. And this is kind of exactly what we kind of want. So how can we go and plug this back into our check constraint? Well, if you remember earlier, I said, check constraints are a bit constrained about what they can execute. Well, we can't actually go and plug this in as a subquery of our check constraint. But this is where Postgres comes to our advantage again. We can define functions, and we can define them in just SQL as well. We don't actually need to use, say, a procedural language here. So we can actually just define a function which is going to check our data type, and it's going to return a Boolean that's valid or not. Now, the only thing we have to pay a bit of attention to here is that we're going to mark this function as immutable. Now, this is because, right, it's always going to return the same result for the same input. And that's a kind of key property that we need for it to be callable from the check constraint. So all we need to do is create this function, apply our statement that's going to do our validation, right? So we're going to check that the document's an object. We're going to check our properties. We're then going to go and expand that array and check all the values there. And so how do we update our check constraint? Well, it's even simpler, right? We just specify in the check constraint, well, just use this function to check my result. And it's going to return a Boolean, right? That's all the expression for a check constraint needs to do is just return a Boolean result, right? So super simple, nice and clean, code looks really nice. This is all working really well. And now we can go a bit deeper, right? Now we've got all this basic stuff working. We can kind of like use that and accelerate and kind of cook on gas a little bit here, right? So we want to actually apply a bunch more checks to that kind of nested object in that array. Well, that's easy, right? We've already learned all the things we need to do. We just create a new function that's going to check that individual, that kind of child object. And it's going to check this an object. It's going to check it's got the properties we want. And again, right, we could specify if we had multiple nested levels, right, 3 or 4 levels deep, we can just define more functions to go deeper. And then we can just put this back together. And then rather than having to write a really complex check expression inside that bool and aggregate, we can just call the function we've created. So we have all the power from SQL and Postgres to be able to create these very simple composable validation functions and call them together and to chain all of that together. But at the end of the day, I said this talk was about schemas, and I've not really talked about the obvious elephant in the room yet. And that would be JSON schema, right? We all know that there is a well-defined, especially if we spend time building REST APIs, we know that there is a kind of dedicated schema for JSON that also happens to specify itself in JSON. So we already have a way to declare the structure of JSON. Well, so here's a kind of brief example cut down for the slide, but we're going to just define declaratively the structure of that kind of example type that we previously wrote a function to validate. We can specify these basic things. So, we expect a property type string, we expect decisions, we can expect that to be a type object and have other properties. We can specify that we want required properties. We can specify whether we allow additional properties or not. So we can kind of already specify all this. We already have a format to specify all of this. And we can make use of that in Postgres as well. And originally I thought first off, it wouldn't be too difficult to write an extension to do this. Well, it turns out somebody's beating me to that, Superbase no less. And there is actually an extension out there that you can go and download called PG JSON Schema. And that's going to let you use your JSON schema that you probably already have defined in your application to validate the data you're going to store in Postgres. So simple case of install the extension. The extension is written in Rust, so it's maybe not always available on every kind of hosting provider. But you can kind of go and download it and install it. And then we can define check constraints just in the way of this, where we can specify that we're going to use the JSONB matches schema function. We're going to provide it the schema, and that's just as a JSON text blob. And then we're going to specify the value we want to validate, and it's going to, under the hood, go and do all that validation. It's basically a fairly thin wrapper on Rust's JSON schema validation framework. So this gives us a very kind of fast and easy way to be able to kind of validate, especially very complicated objects, at the trade-off of having to install an extension. And obviously the extension still works for standard JSON. So if we're not using JSONB, we can still call and use this kind of extension in that particular situation. Now, the only problem and downside here is that, as I said, we've had to install an extension that might not always be an option for us, which is why I think it's still kind of useful and valuable to talk through the build up and basic building blocks of how we can go and do this and solve this with pure SQL. And I'm kind of have a tool that's available on our website where you can actually give it a JSON schema and it will go and generate the kind of at least basic validation functions. So if you're in a situation where you don't actually want to install an extension, well, the other approach here is just generate the kind of SQL validation functions you might need from your JSON schema, and then we can load those into our schema and just use them as we would normally as anything else in Postgres. So please feel free to take a look and try it out. And with that, thank you very much for listening, and I hope you enjoy the rest of Posette.